Welcome to my abstract presentation for the conference CAR 2020. I'm Benjamin Lalande, and I'm a PhD student in the University Pompeu Fabra at Barcelona in Spain. Today, I will introduce you to the multimodal registration of ultrasounds and magnetic resonance scans for vascular fetal surgeries. The team Symbiosis is currently working on the planification and navigation of minimal invasive fetal surgery for twin-to-twin transfusion syndrome. But what is exactly twin-to-twin transfusion syndrome, aka TTTS? Twin-to-twin transfusion syndrome is due to the presence of small anastomoses that connect the blood flow of both fetus. This leads to unequal sharing of the placenta blood volume, resulting in unbalanced growth and severe nervous and cardiac damages. And it is generally fatal if left untreated. To avoid this deadly scenario, it is required to perform minimal invasive surgery in order to cauterize the anastomoses that share the twins. You probably didn't know the twin-to-twin syndromes until now, and so you're thinking that it's a rare disease. But let's have a look at the statistics. Considering 360,000 births per day, with a twin birth rate of 3.3%, with 75% of twins being monochromic, and 15% of them presenting twin-to-twin transfusion syndrome, it gives 133,000 cases per year in the world, and the same amount of potential death. As we introduce, the goal is to register ultrasounds and magnetic resonance images to detect vessels in the placenta. The reason to the choice of these modalities is that their information are complementary. Magnetic resonance images include spatial information, while ultrasounds provide us vessels information. The registration of ultrasounds and magnetic resonance images is done using the placenta masks. These placenta masks have been first done manually by the clinician, then we succeed to perform automatic segmentation using deep learning. Regarding the details of the registration, our final choice is to use affine and B-spline transformations. Nevertheless, we tested several possible registration strategies and found that the best result could be obtained by applying a distance transform to the segmentation masks of both the magnetic resonance images and the ultrasound placenta. This is because the distance transforms creates a gradient that can be followed by the registration algorithm. Here is some qualitative results of the registration. with, on the left, MRI, on the middle, US, with in red the vessels, and on the right, the register images. We can see that the method was successful into bringing both modalities in the same subspace. However, vessels, in red in the image, could be significantly distorted due to the use of the deformable B-spline method. We empirically found that using an energy bending penalization term gives a good compromise between the accuracy of the registration and the absence of significant vessels deformation. In terms of quantitative result, we obtain a dice coefficient of 0.75 in average and a minimum Hausdorff distance of 13. We see that the dice coefficient is never completely maximized. This is because many times the placenta in ultrasounds is smaller than the corresponding one in magnetic resonance images. To conclude, our first approach has shown satisfying results, helping the surgeon to planify their operation. Nevertheless, we are investigating a new approach using deep learning to perform better registration of the placenta and detection of the vessels. Thank you for your attention.